Okay, so hello. Today we are going to review the homework problems for chapter 18, 19, and 20. And after that, I'm going to talk a little bit about our first exam, okay? Um, so I already put the recitation, which includes the homework solution PowerPoint on D2L, which you can see it from here. Okay, so this is for 18, 19, and 20. So when you finish your homework, you can try to check the homework solution from the PowerPoint slides, okay? And today we are going to go over some of them. So I'm going to pull out, we are going to start from chapter 18, and we are going to pull out some of the PowerPoint slides, okay? So for our recitation, because it's our summer class, I do not require you to do the I do not require you to do the FOC problem, which is the focus on concept problem. So we are just going to directly go to the calculations. But for our PowerPoint slides, there are some very good review of vector addition and the definition for vectors and scalars. So you can take a look at the definitions. Okay, so this is the review. Now we are going to go. So here, chapter 18, the most important thing here is Coulomb's law. So we have this equation. It's the electric force F sub E will be equal to K Q1 Q2 over R squared, and the K here is a constant. So if we have two charges, okay, and the force between them will be, the magnitude will be this, and the like charges, they repair each other, and unlike charges, they attract each other, but the magnitude will be equal to this. And then we have this example here. We did this example, which is problem number 5 of chapter 19 in class already, so we are not going to do it again. So problem 5, this problem, the answer is 1.57 Newton, and the angle is 59.3 to the x-axis. Okay, so this is what we did in our class for chapter 18. So, and here we have the solution, okay? You get the angle, so here. You are calculating this angle, okay? You calculate F1, you calculate F1, you calculate F2, and then use Pythagorean theory. Here, you get the total force and you get the angle. So we did this example in our lecture, so we are not going to spend a lot of time on it. And also, we have problem 21. Problem 21 is also using symmetry, which will make this problem very simple. I got emails from some of you ask me to do some specific problems. So problem 21 is the problem some of you asked me to do, so I'm going to go over it with you. So here, we have the drawing shows 3-point charges in fixed place. We have Q1, Q2, Q3. The charge at the coordinate origin has a value of Q1, which is 8 microcoulomb, and the other two charges have identical magnitude but opposite signs. So Q2 is -5, so this guy here is -5 microcoulomb, and the Q3 is +5 microcoulomb. Okay, so what we are going to do is we are going to determine the net force, magnitude, and direction exerted on Q1 by the two other charges. And also, if Q1 has a mass, what is acceleration? So for acceleration, if you have the force, you can have force equals to mass times acceleration. So now we are going to do some analysis, okay? So what is the force by charge 2 on 1? So that's why here we have this picture here. because this is -5 and this is 8, so these are unlike charges, right? One is positive, one is negative. So they will attract each other. So there's a force by F2, by charge 2, it's here, okay? So we can do that. Okay, and then we have another one here is by charge 3. And this is positive, positive, so they will repel each other. And then we have a force will look like this, and this will be our F3. And since they have the same, or they have the same charge, they have the same magnitude. So they have the same magnitude. So F3 and F2, they should also have the same magnitude because F will be equal to K absolute value of Q1, absolute value of Q2 over R squared. So those Q, although they have opposite signs, but they have the same magnitude. So F2 and F3, they should be equal to each other. So that's why we can take a look at this graph here. F2 and 3, they have the same magnitude. So that's why the vertical, you can see the red arrow here, the red notation here, the x-axis of the forces, they will cancel each other, but the y-axis is twice of the y component. So that's why you can read the explanation here. X direction, the forces, they cancel, and the y direction, the forces, it's the double of the y component of F12 and F13. So that's why as long as we get the magnitude of the force, get its y component, and we can get the right answer. So that's why we calculate the force first. It's KQ over R squared, and then you use the numbers, you are going to get the value of the force, 0.213 Newton, and then get the y component. So y component, go back here, it's this is the angle, and y component is the opposite side. So you should use sine. So that's why we have the sine, and we double the number here. So you can calculate the y component for F2 and F3, but they have the same number. So you can just calculate this one value and multiply by 2, and you are going to get 0.166 Newton. So this is the net force. And also for part B, you have to have the mass of the particle. Okay, so the mass is 1.5. So that's why 1.5 gram convert to kilograms. I'm going to make a note here. Convert to kilogram is 1.5 times 10 to the power of -3 kilogram. And use force divided by mass, you can get the acceleration. So this is a problem 21. And so this is also use the different component of the force, and you should be able to get the resultant force, and use force, you get acceleration. Okay, so this is problem 21. And we also, this is a review of the electric field. For electric field by a point charge, it equals to K times Q over R squared. So this is the point charge, okay? So E field by point charge, okay? So this is the E field, and then we can try to do problem 33. Okay, so 4-point charges, they have the same magnitude of 2.4 times 10 to the power of -12 coulomb, are fixed to the corners of a square that is 4 centimeters on a side. 3 of the charges are positive, 1 charge is negative. So determine the magnitude of the net electric field that exist at the center of the square. So we can take a look at the picture here. We can have one corner is negative, so negative A, positive B, positive C, and positive D. And also what you need is you need to get the direction of the electric field. So for this point in the middle, because let's start with A, okay? So for A, the electric field going into the charge. So that's why you can see this EA is like this, going into the charge. So we checked A. I'm going to erase my red join. And then for B, so for B, electric field going outward. So it's like this. So that's why for EB, you can actually draw a longer line. So you can say EB is like this, okay? It's the black arrow that we have here for EB. And then we are good with EB. So this is EB, EA. And then electric field by charge C, also, for positive charge, the electric field goes out. Okay, so goes out, so that's why it's our EC here. And then ED, the electric field also goes out. So this is our ED. And then we have the electric field for the four different charges. So I'm going to erase my drawing. And then you will see what we have is we are going to have the total electric field will be equal to the superposition of all the electric fields. So we have this, but what we have here is ED and EB because they have the same magnitude. See, all the charges have the same magnitude. So ED and EB, they will cancel out each other, right? Because one goes to the upper left, the other one go to the lower right. So these two are going to cancel. So I'm going to write ED and EB cancel. Okay, so they cancel each other. So you don't need ED and EB anymore. But EA and EC, they are both to the lower left corner. So that's why we should keep this, but they have the same magnitude, so we can just calculate EA and do multiply by 2, okay? And then we have, for point charge, what do we have? We have KQ over R squared. But you need this little side here because this is your R, okay? So that's why we can calculate our R. What is this R? R will be, you have to use, so this is our R, okay? I can do this. So this R here, let's do this big one, okay? So this R here is 1/2 of the diagonal. So the diagonal here will be equal to, let's say the diagonal here will be equal to, this D represents diagonal, will be equal to square root of the side plus the side, but we have R is 1/2 of the diagonal, so that's here. That's why we have this equation here. And then we have our R put in here. We have our K is a constant, and we have our Q, which is this value here, 2.4. So this goes to here, and then we can calculate our electric field twice of EA, so you are going to get 54 Newton per Coulomb. So electric field has a unit, Newton per Coulomb. So this is problem 33. And then we have problem 37. Okay, problem 37 is the next problem you guys asked me. Problem 37, you have to understand what is torque. So torque equals to force times the level arm, okay? It's what you have in, let me write it this way. Torque will be equal to force times the level arm. This is what you have in physics 131. So let's take a look at problem 37. We have a long thin rod like here, which is 4 meters. So this is 4 meters, lies along the x-axis. So we have, and this is a three-dimensional picture. So it lies along x-axis is like this here. with its middle point at origin. So middle point is origin. So in a vacuum, a 8 microcoulomb charge is fixed to one end. So this little guy here is fixed to one end of the rod. And then here, negative 8 microcoulomb point charge is fixed to the other end. So everywhere in xy plane, there is a constant external electric field. So we have electric field perpendicular to the rod, and we have the electric field, see, along y-axis. So with respect to the z-axis, find the magnitude of the net torque. So one thing here is what you have to know is we have electric field and we have charge here. You have to understand the electric force. So electric force, we also have an equation. It's electric field times the point charge. So if it's the same direction, the E field and the force will be the same. If it's opposite direction, then it's opposite. So that's why for the negative charge Q, the force is this way. And for the positive charge Q, the force is this way. You can also read a little bit about the reasoning here. So this drawing shows the setup and electric field along the positive y-axis because it has to be perpendicular to the rod. And the electric field applies a force positive F. So this is positive F to the positive charge and the negative F to the negative charge. And each force has the same magnitude, E, F equals to E times Q. So we have F equals to EQ. So what you are going to do here is you are going to calculate the torque. So torque equals to force times lever arm. And then if you remember, this is the z-axis, this is the axis of rotation. So this force makes a torque rotate this direction, which is our counterclockwise. And this is also this direction. Wait, is this counter? Yeah, this is also counterclockwise. So we have to put all the torque together. Net torque will be equal to torque 1 plus torque 2, but you have to calculate force times lever arm for this guy and force times lever arm for this guy. So the force here, the force is EQ. So here, the force is E times Q, and the lever arm is from here to here, which is half of the length of the rod. So that's why EQ times L over 2. But you have to add this torque to this torque. So that's why we have here the magnitude of the net torque will be equal to EQ times L over 2 plus EQ times L over 2. So put them together, you are going to have E field goes to here. Your Q is 8 times 10 to the power negative 6 because it's 8 microcoulomb, and the L it's 4, but you have 2 of them. So that's why the over 2 get crossed out, and then you have 0.16 Newton meter, and this is the torque. Okay, so this is a chapter 8 problem. Chapter 8, chapter 18 problem. And I also put the answer for your FOC, the focus on concept problem, and its answer here. So if you want to review the chapter, you can read that. And we are going to go over chapter 19. I checked my email. Nobody asked problem about chapter 19. You only asked problem about chapter 20. So let me just go over the concept for chapter 19 with you, okay? So let's do a quick review of the concept. So chapter Chapter 19, we talked about the electrical potential. So the electrical potential for the point charge will be equal to KQ over R, and also potential will be equal to electrical field times R, and electrical potential energy is the work done by the electrical force. So it will be the change of electric potential energy will be equal to Q times V, okay? So you should see Q times delta V. So this is that. So electric potential energy for a given point is EPE will be equal to QV. So if you calculate the change, it's Q times delta V. So this is the concept. And if you want to calculate the net potential, you are going to do a superposition, actually the summation of the potential by each charge. Okay. So problem number 3 is very simple. You have your delta V is this, so your energy will be equal to Q times delta V is 1.1 times 10 to the power negative 20. So this is that, and also delta V will be equal to E delta S, and you are going to get 3.5 times 10 to the power 4. So problem here is very simple. And also, if you want to calculate the potential difference, so for point charge, it's KQ over R. So you just do KQ times 1 over R, and you are going to get 38 volts. And also work will be equal to Q times delta V. So you have the work and you can calculate your Q. And the last problem is more difficult, but you are going to calculate the potential in the middle. So what you do here is you calculate the potential by each charge. So we have the negative. Now we can start from the 7, and you have this distance. The 3, you have this distance. The 5, you have this distance. And another 7 go here, and the negative 3 go here, negative 5 go here. So you have 1, 2, 3, 4, 5, 6. 6 charges. They all contribute to the potential here. And some of them can get crossed out, which is this guy, and this guy, this guy. And you only have these 2 left, and you do the calculation. You are going to get 7.8 times 10 to the power 6 volts. So for point charge, remember it's KQ over R, okay? And problem 51, and also energy, it's power times time, and here we here energy is 1/2 CV squared. So we didn't go over this calculation in this concept in our class, but the energy stored in a capacitor is 1/2 CV squared. So 1/2 CV squared will be equal to this energy times the 60 seconds of time, so 4,500 joules, and it will be equal to 1/2 CV squared. And then you can calculate your V here, okay? And the last one here, it's the an empty parallel plate capacitor connected between the terminal of 9 volts battery and charged up, and then capacitor is then disconnected from the battery. So, and the spacing between the capacitor plate is doubled. So as a result of this change, what is the new voltage between the plates of the capacitor? So what we have here is we have Q. So once you disconnect the capacitor, the charge will not change. So you can calculate your Q first. So Q for capacitor will be equal to capacitance times V. So that's why here we say Q is the same. So Q will be equal to CV. And V initially is 9 volts. So you do epsilon 0 A times D over V. Okay. So this is initial charge. So you have the 9 epsilon 0 A over D here. So what's the next? The next one here is we are going to double So we are going to double the space between the plate. So what we have here, it's, okay, this is a 9, okay? It looks like a cube, but this is my number 9, okay? So Q will be the same. You are going to double the distance. So instead of, you have V times epsilon 0, A. Instead of the D, we have 2D, right? So 2D, the D will get a cross out, epsilon 0, A get a cross out. So you have V over 2 equals to the 9 here. Okay, so this is 9. So that's why you have 18. Okay, so double. So remember, when the capacitor is being disconnected, the charge will not change. So that's why the Q stays the same, and you have Q equals to 9 epsilon 0 over AD in the beginning, and then you have V times epsilon 0 over 2D in the end. So double the distance, you are going to increase the voltage. So this is chapter 19. So chapter 19, I didn't have any questions asked for me. So I'm just going to, I just quickly finished that, and we are going to go to chapter 20. So chapter 20 is about, eh, okay, so I'm going to, where's my chapter 20? So chapter 20 is about the electrical circuit, okay? So you have the definition of current, which is delta Q over delta T here. Delta Q over delta T here. And problem 1, nobody asked me this. So let me go to the problem that some of you asked. We are going to go to problem 80. So we are going to go to problem 83 first, and then we are going to go to problem 105, okay? So let's take a look at problem 83 first. Here, determine the current, both magnitude and direction in the 8 and 2 ohm resistors in the drawing. So you are going to determine the current here. And we are going to assume the current flow. Okay, so we are going to assume this current flows this way. Okay, and we are going to label this I2 because it went through R2. And we are going to assume the current flow this way. And this is I1. And we are going to use Kirchhoff's loop rule to do the problem. So how to do that? You can we can label the potential difference. So here we have, so when the current goes through the resistor, it flow from here to here, you are going to have potential drop. So we have positive here, negative here. And then also here, you are going to have positive here, negative here, okay? So for here, we have a potential drop. So what do we have? So we can choose. See, this is a small loop. Okay, so we have potential rise, which is, so see this loop. Go from negative to positive, we are going to have a potential rise. So that's why it's 12, okay? And then minus I2 times R2 will be equal to 0. So I2 is actually very easy to get because this is 12. Okay, and then we are going to take a look at the bigger loop on top. Okay, so from negative to positive, this is 12 volts, but this 4 volts, you see the loop here is also a potential drop. Wait, Let me erase this little thing. We are going to take a look at the bigger loop. Okay, this little bigger loop. So what do we have here? From negative to positive, we are going to have a potential rise 12 volts. And this loop here, from negative to positive, we are also going to have a potential rise. Okay, so it's plus 4. Negative, this loop go from negative. So the loop go from negative to positive, and then goes through the charge is positive to negative, so it's a potential drop. So we have I1 times R1 and equal to 0. So our R2 here is 2, so you can have 12 minus 2I2 will be equal to 0. So you have I2 will be equal to 6 amp. And then for R1, you have 16, and then minus 8 I1 equals to 0. So you are going to have your I1 is 2 amp. Okay, so that's why 6 amp and then 2 amp, and they are all from left to right. Okay. I chose this loop, and I also chose this loop. Okay, so but A, B, C, F. In this problem, the solution chose the small loop here and the small loop here. As long as you have a complete loop of the circuit, you can choose anything you want. I think my way is easier because see the smaller loop here is just 12 and this R, and the big loop here, you have 12 and you have 4. So this loop, negative to positive, remember, is a potential rise. And when the loop goes through positive to negative, it's a potential drop. Okay, so this is why you have positive, positive, and negative. So negative means potential drop. Okay. So this is a problem 83. Let me pull out problem 105. Why my problem 105 is not here? Okay, let me copy it here. Okay, so this is problem 105 and we can do it together. So the circuit in the drawing contains 2 resistors and 2 capacitors that are connected to a battery and with a switch. Okay, so when switch is closed, the capacitors begin to charge up. So what is the time constant for the charging process? So for this problem, what you need to do here is you are going to calculate the resistance here, and you are going to calculate what is the capacitance here. So remember from our PowerPoint slides, I don't know if I have it here. Oh, I have it here. Remember from our PowerPoint slides, what we have is we have, if your capacitor is connected in parallel, then our CP will be equal to C1 plus C2 plus C3. And our resistance is in, so see here, our resistance is connected in parallel, then our R will be equal to 1 over R1 plus 1 over R2. So for this picture here, we are going to have our 1 over R will be equal to, so let's label this as R1. label this as R2. So 1 over R will be equal to 1 over R1 plus 1 over R2. And the capacitance, because they are in parallel, so we are doing C1 plus C2, is the opposite of the connection of the resistance. And our time constant is R times C because we are going to calculate the time constant for the whole circuit. So that's why we can do R times C. So calculating the R, and we have kilo. So this is 1. So 1 over R will be equal to 1 over 2,000 plus 1 over 4,000. Kilo is 1,000. And then you are going to get your R, it's 1,300 ohm, okay? And then you'll get your C will be 3 times 10 to the power of negative 6 farads, C1 and C2 plus 6 times 10 to the power of negative 600. So you are going to get 9 times 10 to the power of negative 600. Oh. 3 times 10 to the power of negative 6, no 100, plus 6 10 to the power of negative 6 farads. So you are going to get 9 times 10 to the power of negative 6 farads, and then time constant will be equal to R times C. So this multiplied by this, and you are going to get 12 times 10 to the power of negative 3 seconds, which is 12 milliseconds. Okay, so this is the time constant. And problem 105 is also our PowerPoint. It's just not the last one. It's here. Okay, so. And also we have some, for chapter 20, we have some alternating current problem, and you are going to use I0 over square root of 2 to get the root mean squared current. So this is all our problems. Okay, and I already put these solutions on D2L. You guys can take a look if you don't know how to do it. So I also want to talk a little bit about our exam tomorrow, okay, before we stop our lecture here for today. So let me put my exam out. Mm. Wait for a little bit. I'm going to pull out my exam. Okay. Oh, I don't have that. Oh, I cannot show you the exam tomorrow, but I can show you how the exam looks like. Okay, so I'm going to. Okay, I'm going to show you how the exam looks like. Okay, so the exam looks like this. We will have a multiple choice. So the total exam is 50 points, and we have about 20. So this one here have 15, but for our first exam, we have about 20 multiple choice problem. So you can take a look at my multiple choice problem. So you just need to wait for it. I'm going to create an answer sheet for you. Okay, so you have 20 multiple choice problem here, okay? And each problem is 2 points. So that will be 50 points. And then you have two very small calculation problem, okay? So the calculation problem will be very similar to our homework problem. They are the same. I just change some numbers. So this is second part. So first part, you have 20 multiple choice, and second part, all the multiple choice problem, don't overthink it. They are usually very simple. You only need maybe one line of calculation to get the right answer. But the most important thing I want to tell you guys is you have to, when you submit your answer, how to do it. Going to. Okay, I will let me create an answer sheet for you guys at the end of the exam. So we are going to have 1 and then 2 and then 3. So I'm going to create an answer sheet for you. You put all your answers in the answer sheet. So if you want to submit your exam by hand. So if you don't want to do it electronically, if you want to do it by hand, you are going to have the same format as my answer sheet. Okay, so you are going to put the first 10 multiple choice problem in the first. So how to do that? If you want to do it by hand, you are going to have 1, 2, 3. Mm -hmm. Okay, so you are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so write your answers A, B, C, D, and this is your first row. Okay, and the second row here will be 11 and the B, something like that, 12, and then all the way to 20. So first row is the first 10 multiple choice problem. The second row is the second 10 multiple choice problem, and then in another row, you are going to have calculation, okay? And then you are going to have your problem 1 here. You are going to have your problem 2 here. Okay, so calculation 1 is about a potential problem, okay? I'm going to give you some of the charges and ask you to calculate a potential at somewhere here. And the second problem, it's a circuit problem, okay? I'm going to ask you to calculate the current go through different charges, okay? So these are the two calculation problems. And the multiple choice problem covers all the concept we went over in our class. So make sure when you submit your answer, even in a blank piece of paper and you handwrite your answer, make sure you have your first row, your second row, and your calculation. First problem, second problem, okay? I cannot show you the actual exam today, but this is the format. And the calculation problems, we all went over them in our class. They are very similar to our homework problems, so don't worry about it. Don't worry about it. You don't know the calculation. And our multiple choice problem is open book, open notes. So it's a very good review of the concept we went over for our first chapter. Okay, so make sure you take your time to do the multiple choice problem, and then we are going to, you will have tomorrow from 9 all the way to 11:59 p.m. to finish your exam. So take your time to review the concept and try to get all the multiple choice problem right. So calculation is 10 points, okay, 5 points each. And the multiple choice problem each is 2 points. Okay, I will create a similar answer sheet like this for you in your exam, but make sure if you don't do it electronically, get your handwritten submission the same format as what we have here for You only need to have 1 page of submission, okay? So the first 2 row will be the multiple choice, and then you have the exam. Yes. There's no time limit, but we have a due date. So we have the exam start at 9 and end at 11:59. So after 11:59, it will count towards late submission. So you have actually, if you count the hours, you are going to have 14 hours to do the exam, but you won't need the 14 hours. Does that make sense? So I didn't put a limit of the time on your exam. I only have the start time and the due date. So due date is 11:59 p.m. tomorrow, and start date is 10 a.m. tomorrow. So the 14 hours you can do the exam. So make sure you get the problem right. Okay. It shouldn't be very difficult for you guys because in a regular class, this exam is taking in an hour, but I will give you more time than hour for the exam. So make sure you get everything correct. Okay. So this is the exam, and I don't have other things to tell you right now. Oh, you have a lab that is due today. Some of you already emailed me about the lab. I just made the video yesterday night, so you should have the video for the second lab ready. You are also going to do a simulation with resistors connected in series, in parallel, and in combination in the virtual setting. So you can have the voltmeter connect to the resistors. You have ammeter added to the circuit, and you are going to change the power supply of your battery, and you are going to have 3 data table, and each data table you are going to have a graph. Okay. So you should be, as long as you follow my instruction, you should be okay to finish the lab. And we are going to stop our class today, right now. And just don't forget to submit your exam tomorrow, okay? I will post it on D2L later today. But the start time will be tomorrow at 9. You cannot see it until tomorrow at 9 a.m. Okay, so bye bye. Thank you for coming today.